So what I would like to do now is show you a real practical example of why and when we may want to use object-oriented programming. As well as that, I'm going to show you a couple of shortcuts to make things easier for you. You will notice there's a lot of repetition. I'll show you how to shorten that down. So this is my second lab assignment for my Introduction to Programming class, where we just learn variables for the first time. So I asked you to calculate the area and perimeter of a rectangle. There's no user input involved. I give you the width of 4.55 and the length of 8.25, and then you display it just using some system.out.println, referencing those variables and performing the calculations. You can pause the video and read this if you'd like. It's a fairly simple program, hopefully, for this level of programmer where you should be at now, and here is the solution. Right, so I assign, well, obviously these numbers are wrong. Let me jump back and see what the numbers are. 4.55, so this would be 4.55, and this would be 8.25, I believe that said. Yes. So if I run this, do we get the matching output? 37.5375. We do, and a 25.6 width. We do indeed get all of that. We have a couple of spacing issues, but nothing we will worry about at this point. So why am I bringing object-oriented programming up to lab assignment 2 from Introduction to Programming? Well, imagine if you had this assignment, and I said, okay, create a second rectangle. Second rectangle, that's easy. I just have to change the variables up here. So if I change this to 12 and this to 14, there's your second rectangle. Well, no, I want a second rectangle on top of the first, so I want to see both at the same time. Okay, well, with this, what I would have to do is I would have to, let me just call this R1, R2, I'd have to paste the entire program again. Of course, that causes issues because same variable names. So length 2, width 2, perimeter 2, area 2. Have to change all of these variables as well. Make sure I get all of them. Change this to 10, and this to 15. And then we'll put an S out here just to separate that. And here's my second rectangle. That wasn't so hard, but look how messy my code is now. Repetitive and messy. Imagine if I wanted a third rectangle, or fourth rectangle, or fifth rectangle. It would get crazy messy, right? You could copy and paste your way through it, but it wouldn't be ideal. So this is not what we want to do. We want to, of course, use object-oriented programming. And to do that, I have already created a rectangle client class for us and a rectangle demo class. We are first going to do it without a constructor, just to remind you how that works, and then we will use a constructor. Like I said, I will show you some shortcuts here, so it is important to pay attention to this video. The first thing I'm going to do is create the variables I'm going to need. In my client class, I know these are private. There will be private doubles. We'll say length. I'm going to assign it to 1 as a default value. Width will be 1. Perimeter, I'm not going to assign to any value because I don't know the perimeter or area just yet, depending on what the users have given me. So now, of course, we need getters and setters for each variable. But think about this. We don't need setters for perimeter and area because the user isn't going to set the perimeter and area. Those are calculations, right? We can't set a calculation. For example, I can't say, or if I order something at the restaurant and say, my bill will be $5. No, I don't set that. The restaurant sets that. So we don't have control to set the perimeter and area. We want to set and get the length and the width, but we will get the perimeter and area, not set them. Okay, so if I remember correctly, in order to do this, you have to go up to source. It's a little bit off my screen actually, but at the top left of your screen, you want to go up to source, and you are going to press insert code. You could also press alt plus insert on your keyboard, but source at the very top and press insert code. When you do that, you are presented with this little drop down, and we can do setter or getter and setter. And for getter and setter, all you have to do is check the boxes you want getters and setters for. I told you it was going to be length and width we want getters and setters for. When you press generate, There's your getters and setters. You don't have to write them. We return the length, private equals public. We return the width, private equals public. The this keyword is something we will talk about in a future PowerPoint. You don't have to worry about it too much right now, but just to go over it very briefly, this is referring to this particular object at this particular point in time. So if we had two rectangles, how do you tell the difference between two? The first rectangle, R1, is this rectangle, the one I'm referencing now, R1, and the second one, when we reference that, that will then be this, R2. So this just refers to an object in this current space and time. If you have multiple objects, this refers to itself, if there's many of the same. I'm going to do that shortcut again, so up to source and press insert code, and we would like some getters for area and perimeter. Remember, we don't need setters for those. And there are our getters. Now, our getters and setters for length and width are fine because users will define them, right? The users will define what the length is and the width is, and that will all be set. What I don't like with the shortcut is how it names our variables the same as our private, so it gets a little confusing. I would honestly change this to L, but it's not too big of a deal for us here. So, what we're going to do now is change the perimeter to the actual perimeter formula. We can find that over here or in the assignment sheet. But the perimeter formula should be returning 2 times whatever our width is plus 2 times whatever our length is. And area is a lot easier. It's width times length. Right, so we can't just return perimeter, because what is perimeter? And we can't just return area. We need to return those formulas, and that's why we're not allowing setters for these. We don't want the user to define what the area formula is. That's set in stone and should not be changed. This is our entire class so far. We will add various aspects to it, but for now, this is our entire class. We are now ready to create our first object, so we can come over here, we can say rectangle client R1 equals new rectangle client. We've created a rectangle client object. You can see it is blank, invoking the default constructor, which currently we don't have, but that's okay because there is one built in. It just doesn't do anything. Let me throw in a rectangle 1 output here. And we'll say something along the lines of length is R1 dot get length. Width is R1 dot get width. Perimeter is R1 dot get perimeter. And last but not least, area is R1 dot get area. And this spacing is a little off, so we just do this. This tells us the rectangle 1 has a length, an area, and perimeter of all of these values. It's a little messy, much like we saw with our original animal example, and that's because of the lack of constructors. So every time I want to reference a variable, I have to use the getters to do so. Right, we should probably clean that up. So let's go ahead and clean that up with the use of toString. So I'm going to come over to rectangle client, and I'm going to make a public string toString method right here that will return a string, and we will neatly format that string to be the output of what we, so we can say something like a rectangle with the length of length, and then hit a new line, and a width of width has a perimeter of perimeter, and an area of area. A rectangle with a length of length and a width of width has a perimeter of perimeter and an area of area. So now, if I come over here and I create a rectangle client R2 equals new rectangle client, I can simply print R2. Let's put a \n here to separate it, and on top of here we'll say rectangle 2. Run this. Whoop. Just clean up the code a little bit. There we go. Okay, so here's rectangle 1, which required all of this work, and here's rectangle 2, which is a lot cleaner and a lot less code, because we're using now the toString method, which neatly formats, let me add the override here, that neatly formats our object to be a rectangle, or what we expect a rectangle to return, which is this string referencing these variables. Now let's go another step. So the next step here is I could create yet another rectangle, so we could say R3, and if I don't want the rectangle to have 1 and 1 for the length and width, I could say R3.setLength to be 10 and R3.setWidth to be 5, and then print R3 here. Change this to rectangle 3. And there we go. There seems to be an issue with the perimeter. Actually, I just noticed that now, so let's figure it out. Oh, I figured out. The issue is perimeter and area actually don't have values, so we need to change this to the method call, which will return the value. So this should be get perimeter and get area. If I rerun this, everything, that's why the first one was working, because we were actually calling the get perimeter and get area methods. The second one had 0 for each, and that's because we were printing the value that didn't of perimeter and area, but we never initialized them until they are called. So by in our toString calling the method, which is the variable, it works a lot cleaner that way. And here we go. We can see that when we set the length and the width, we get that rectangle that way. But we know this is not the most efficient way or the best way to do it. We know that we could do it with constructors a lot cleaner. So what I'm going to do here is I am going to do a save as on my rectangle client, and I'm going to call this rectangle client constructor. Rectangle client constructor, make sure we name it correct. And we are going to create a couple of constructors here. This will be my default constructor. And then, of course, we will have a overloaded constructor. You will notice that I have a red line, and that's because I have 2 constructors with the exact same name. That's not acceptable. So let's overload this one with a double of length and a double of width. So if you invoke my default constructor, we'll say that length equals 1, and we'll say area equals 1. We will then say area is equal to get area, and width is equal to get width. So if you invoke my default constructor, you don't give me any parameters. Length is 1, area is 1, area and width have these values. Otherwise, if you invoke my overloaded constructor here, then everything's going to be pretty much the same, but instead of length being 1, it's going to be L. That is very misleading because the 1 looks like an L, but this is an L, and the area will be, oh, sorry, why did I put area here? This would be width. Width, okay. So the default would have a length of 1, a width of 1, an area of get area, and a perimeter of get perimeter. Moving too quick, slow down. So length is 1, width is 1, area is get area, perimeter is get perimeter. Length is L, not 1. Width is W, area is get area, width is get width. Everything else can remain the same. These variables will reference the correct thing. Based on the constructor that was invoked, one of these two things will happen. So over in my rectangle demo class, we'll say with constructors, I will make a rectangle client constructor object called R4 equals new rectangle client constructor. This is default, so we won't pass it anything, and we'll just print R4, and I will do a little message up here that says now with constructors. Okay, so we shouldn't need this. So it says now with constructors, rectangle 4, there it is. And notice that I didn't have to do anything here. It's pretty much the same thing. We could just set our own default values inside of the parameters here if we wanted to. Next, our last one is going to be pretty much the same thing. So let me just copy and paste here. This will be R5, R5, print R5. And here, we'll just give it 10 and 5, much like we did in rectangle 3, 10 and 5. But see how much cleaner it is here. We save 2 lines of code. Doesn't seem like a lot, but if you had multiple rectangles, 2 lines of code for every rectangle, by the time you've created 100, you've saved 200 lines of code. We should do a \n here, just to separate that. You can see that when I pass it the overloaded values of 10 and 5, it comes into here, realizes that we gave it a double and a double, and it assigns the private to the public, calls the appropriate variables, and then the toString method prints out the return statement of that string. Everything is clean. So that is a practical example of how we could take a program, in this case it was this assignment that had no object-oriented programming in it at all, very simplistic program, and turn it into objects. So what we did here, and what we ended up with in the end over here, was 3 lines of code. And you don't really have to count the systems.out.println rectangle 5, right? That doesn't really matter. It's really this line and this line. 2 lines of code to create one rectangle, instead of what we did earlier, where I copy and pasted this, which is about 15 lines of code, roughly, for one rectangle. 2 lines of code or 15 lines of code. You can see how useful object-oriented programming can truly be. And you learn the shortcuts of inserting the setters and getters if you wish to do that. I do believe that you can also insert constructors in here, equals methods, and other things as well. So hopefully this was useful. We will be bringing up this example again in the future, but for now, that is it.